Hello.
Hey, what's happening?
All going good? Yourself?
Oh, I'm okay. I'm okay. Not too bad. Not too bad.
Excellent.
Re- We're ready to make another video today, right?
Absolutely. And can you
So,
tell what's behind me?
yeah, I'm looking at that and I see, well, I see something where it looks like you're taking a value of X, subtracting it from the mean,
Mm-hmm.
squaring it. Oh, subtracting it from the X bar, squaring it. That looks like standard deviation. Oh, no, no. That looks like variance to me, but then you're square rooting it to get standard deviation.
Yep.
All right.
Yes,
But then,
exactly. It's kind of cut off at the end over here, but over here should be standard error equals.
that's why that square root of one over the square root of n is there.
Yep.
That's
So,
right.
so
That's
standard
right.
error. Sorry.
No, 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 go ahead, please, please, please.
I was just going to say, standard error and standard deviation are very similar to each other because this part being standard deviation, but we've got this here to represent the difference between that and the standard error.
Okay, so I guess we maybe like so to what's the basic difference between standard deviation and standard error, right?
It's, yeah, standard deviation, to explain it really poorly, standard deviation is to do with what's inside your sample. But standard error even is to do with what the population is. Even if we don't know what the population is, if we were to take a sample and a different sample and a different, all the same population, how far away do these samples differ from the population mean?
Right. Okay. Okay. So there's an underlying standard deviation for the population that we're talking about,
Mm-hmm.
but then we're talking about standard error when we start sampling from that
Yes.
particular population. I got
Mhm.
you.
So that is what this 1 over square root of n sort of represents. Is that we've got a population, but how can we sample that population?
Yeah, I see. So the bigger the value of n, right?
Mm-hmm.
You get basically a better and better and better estimate of what I guess your true standard deviation, right?
Mm.
No, no, no. Is that right? Am I thinking about that correctly?
Your true mean, yes, because when this n increases, so does this n.
Okay, so as you're going towards little n becoming the population, the size of the population, that's when you would know exactly what your mean is, and there'd be no discrepancy.
Yes.
Got you. Okay, well, that makes sense. So, all right. So depending on the sample that we have, we might want to talk about two distributions, right? We might want to talk about two different distributions, two different population distributions, and then talk about how different they may be according to how much we sample from each one.
Mm.
All right, okay. Should we try to use maybe some graphic representations of all of this?
Sure, I think that
All
would be good.
right. Well, I don't know if I've got any special code for this somewhere.
Okay.
Let me see if I can find something here. Oh, how about that? I just was able to find something
Hey,
specifically on this topic.
what are the
Amazing,
odds?
amazing, amazing. Let me see if I can share it now. I'm building it up so much. Now that everybody believes that this is all up here by chance.
Here we
All
go.
right. All right. So what I've found that I've done in previous, sometime previous, is it looks like I've got some kind of looks like I'm trying to build some kind of a distribution. In fact, I've got the comments here that say normal distribution. So it
Mm-hmm.
looks like I've got two different values here, right, for two different means. So I've got 1.86 and 0.701, I guess, for the mean for the first distribution and the standard deviation for the first distribution.
Mm-hmm.
I'm not sure where these numbers are coming from, but here's 1.555 as the second mean with the standard deviation for that second distribution at 0.32. All right, cool.
Cool.
So in fact, here's what I'm doing first. Might as well explain kind of what's happening in this code. I'm making n equal to 100,000, And what I'm doing, well, after I set my mean 1 and my standard deviation 1, my mean 2 and my standard deviation 2, I'm using this function here, R norm. So I want a random normal distribution to be produced. And in this case, I'm using 100,000 points. So this is not really the sample size that I'm talking about or the population. I guess you can call it the population size would be this value of n, since I'm creating it from 100,000 points. I guess you can say that, but I don't want it to be confused with the sample size that we're going to be taking, lowercase n1 and lowercase n2. So just to make that distinction here, this n is just to produce this this random normal distribution using the function R norm. So how many points do I want? 100,000. What's my first mean and what's my standard deviation for that first distribution? I'm calling that n1. So producing n1 here is going to be 100,000 points, it looks like. And in fact, if I ran that, we see that it only showed the first 1,000, leaving out the other 99,000. So these points are all random. They're generated from a random normal distribution with those particular means and standard deviations. So let's create a second one now for n2. Okay, that's with the second mean and second standard deviation. And now all I'm doing is creating a data frame that's going to list both of those distributions. So it's going to end up being 200,000 values. The firsts of which are n1, the second of which are n2. First 100,000 n1, second 100,000 n2. All right.
Sounds good.
So far, so good. And then this is, I could kind of include the script too if we need to. But I'm just creating a title here for these really nice plots I'm hoping will work out. I'm creating here, actually, what am I doing here? Oh, I'm getting the means of those distributions so I can actually print those as well on this graph. And I'm setting up some limits here for my graph. And then I'm using ggplot with a bunch of commands here. And again, I'll probably include all of this code so that people can reproduce it if they want. So what I've done here, have I done this correctly? I hope I've done this correctly.
Oh.
I was expecting these to be a little bit bigger here. Be honest with you.
I don't see n and sn in your environment. Did you run that one?
Let's see. Hold on. I may not have. Okay. These particular ones here?
So line 17.
This one right here? Let me try that. I may have skipped over it. Yes, I think that was right. Thank you so much for that.
Excellent.
Thank you so much for that. I was expecting. Okay, beautiful. Thank you.
Thank you.
So in this particular case, we have our two different distributions, right? Using the means, using the standard deviations that we've defined. So we can see kind of there's a good amount of overlap there. Okay. And if we, it says my internet connection's unstable.
Oh.
Am I back? Am I back?
You're fine with me.
Oh, okay, because it said it was unstable. So
okay.
here I'm actually looking at the two different distributions, how much they're overlapping. So I may want to ask the question by taking samples of each one of these, right? If that true difference is you know what? And I got stuck here. I think when we say the standard, I got a little confused there. When we say the standard error, right? When we're looking at the standard error,
Mhm.
we're looking at these particular distributions now, but how far away they may be from their actual value from the actual mean of that particular distribution.
Mm.
Correct? Okay, so in doing that, when I go through here and I create two different distributions now and take into account that I'm looking at a sample of 10 and a sample of 11 as an example, how those distributions change, basically, right? So what does it mean? Again, 100,000 points are going to be generated here, but now I'm actually taking and dividing by however many in my sample. So
Mhm.
I'm taking my standard deviation and dividing by that value of square root of n. So let me run this. What happens here, all right, let's see if we can interpret this, because I'm a little bit confused, to be honest with you, what we're actually looking at. Okay, so let me make this nice and big. Okay,
Mm.
so this is taking this particular, and I tried to keep the same scale for both of those. So this is the one that we're looking at right now is after we've divided by the square root of n.
Sure.
And the previous one is what we had before we divided by the square root of n.
Mm.
So when looking at this, right, if I'm looking at how much that these standard deviations, right, they've been scaled down. I think I'm understanding it a little bit more now. As these standard deviations have been scaled down,
Mhm.
right, I'm actually seeing if there's a significant difference between those two populations. So I know, as an example, in this particular example that we're showing, we know what our mean and our standard deviation
Yes.
are.
Mhm.
Okay. Now, in trying to figure out, okay, so there is a distinctive difference in the means. Okay.
Mhm.
Now, if I'm sampling both of these different distributions, am I able to figure out if there's a distinct difference between those means? And I get a better and better and better idea if they are truly different, the bigger and bigger my sample gets.
Mm.
Does that make sense?
I think so.
So instead of, it's like if I've got, as an example, this much overlap of what I'm seeing right here, if you can see my cursor, this is the amount of overlap I have over these two different distributions. But that's coming from a sample size of 10 and a sample size of 11. Right? If I've got bigger sample sizes, I've got more information, don't I?
You do.
So the precision becomes somewhat a little bit better, doesn't it?
It does. Yes.
So let's see what happens now if I take these and change it to 100 and to, let's say, 110. Okay, let's see what happens. So I'll change those values.
Mhm.
I think I don't have to worry about. Oh, actually, I might as well just reassign n equal to 100,000. It doesn't hurt, of course. The
Sure.
same mean, the same standard deviation, except now we're dividing by the square root. Instead of square root of 100, we're dividing by the square root of, sorry, instead of dividing by the square root of 10, dividing by the square root of 100,
Mhm.
and the square root of 110. Let's see what happens here. So we should get something that's a lot tighter, I imagine. Using the same limits as before. Hopefully this makes it even, yeah, I think that's what's
Hey.
happening. Is that hopefully? I don't know. Okay.
Nice.
It's
Well, we
I
don't have
mean,
any of them
now,
all now.
Yeah, now it's like you can see they're totally separated. I mean, this is again, this is where we assume that the actual standard deviation of the sample and its mean hasn't changed from what we said. What
Yeah.
we said, we're just saying, well, we've gotten this mean and the standard deviation for these two different distributions, but now instead of just getting those out of 10 points or 100, we're getting them out of more and more and more points.
Mm.
So that means that variability, how far away we are from the true mean, the true means of each one of those is getting a lot tighter, right? Yeah, I think that makes our point here, doesn't it?
Mm. And the actual area of what's underneath the curve hasn't changed. And because it's got thinner, it's got taller as well, because our density has changed quite a bit, hasn't it?
That's exactly right. That's exactly right. It's still all representing 100%.
Yep.
Yeah. Bingo. How's that?
Cool.
Is that okay? Is that enough? Or do you think there's anything more to cover?
That satisfies my curiosity.
Okay. I'm glad we were able to cover it in a decent amount of detail, I guess, but we don't want to bore everybody, right?
Not today.
We've been
We'll do it another day.
Not today, not any day, of course, but all right. So should we call it? What do you think?
Let's do it. Until next time.
We get this business going. Remember, the more and more, if the students are gonna take one thing out of this lesson, this is what happens as you get closer and closer to the population, as opposed to the sample, or the sample being closer and closer to the population, I guess. More and more points.
Yes.
I just ruined that whole video with that last take, didn't I?
Not at all.
No.
I love it.
Save myself and end it now, eh?
All right. I'll see you next time.
Laura. Absolute pleasure. It's always nice to see you.
You too.
I'll talk to you soon.
Bye-bye.
Bye.